Yeah, that's about it. Thomas, take it away.
Hello, everyone. I'm Guilty Gyoza. Thanks for the warm introduction. Today, I want to talk about coordination avoidance, rethinking decentralized network beyond consensus. Now, I think from first glance, coordination avoidance may sound very strange because this industry is founded on top of algorithms that encourage coordination, not avoiding it. But there's a technical meaning to that we'll get to. But before that, let's talk about global consensus. So Ethereum gave us global finality in a trust minimized flavor. It is a truly unique system, one of a kind. But we all know that Ethereum operates on global consensus, which is sort of the finality algorithm is the modified two-phase commit protocol where the supermajority among all the validators have to agree on a certain block for it to be finalized. And the consequence of running a consensus mechanism globally leads to, number one, latency issues. So latency is heavily dominated by consensus, which means that the system is not highly responsive. Also, the cost of transaction is dominated by having to run global consensus. These fees of transactions make layer one really unsuitable for very frequent interactions, which actually is outside of the scope of its design. So that's all well and good, but as a result, we have a world computer that is not really suitable for interactive, content-rich kinds of applications. So we're asking the question, is it possible to make decentralized applications that are actually responsive and free of cost to use? Enter local-first software. Local-first software is kind of software that functions on the local device seamlessly, and it uses the global network only when it needs to synchronize with other replicas or users, or it needs to perform a remote backup, for example. How does it do that? Local-first software places a copy of the application state on the client side so that the client side are essentially only interacting with the local copy or a replica of the state. Behind the scene, these copies on a network synchronize among each other to maintain consistency. The key advantage of this architecture is, number one, applications become super responsive because locally you can read your write and observe its effect immediately. It also gives you offline capability. Just like the Git protocol, you can edit your local clone of a repository at any time. You can synchronize with the remote repository when you want to, or where the internet is available. But how is concurrency handled? If everyone is editing their local copy of the same application at the same time, how do you handle consistency and collisions and so on? Well, we talk about CRDTs. CRDTs stands for conflict-free replicated data types. It's a kind of data type that is, whose instances is replicated across many machines, and when these copies are synchronized, they would synchronize just fine without any conflict whatsoever. If you have no conflict to deal with, you don't have to resort to ordering systems or voting systems. That means that you can run a distributed application without using consensus mechanism. So it's a spatial data structure that I like to call it a multiplayer data structure. It allows you to build multiplayer software. So the mathematical guarantees behind CRDTs guarantee that whichever way you merge these different copies of the same piece of data, you will always get the same result without having to resort to a central coordinator or resort to voting mechanisms. Famous case study would be HackMD. It's the collaborative note-taking applications that we all love to use. It started off with the operational transform approach, OT, which is a predecessor to CRDT that's more than 20 years old. But the HackMD later adopted YJS, which is a very popular open source CRDT library written in JavaScript, which also was rewritten in different languages, including Rust and Python. The motivation of HackMD adopting YJS is that it wants to support offline editing capability. It also wants to allow users to manipulate the folder trees concurrently. OT was designed strictly for text editing. It's difficult to generalize to more complex structure for OT. And CRDT was designed specifically for that. And as with all engineering approaches, there are limitations. CRDT is not a silver bullet for all possible multiplayer software. We can look at 2 case studies. The TL Draw is the pretty popular multiplayer canvas application when users can draw on the same whiteboard, prototype designs together. They also integrate AI, so you can generate drawings. TL Draw initially used CRDTs, but they dropped CRDTs because of performance issues. So imagine you're on a collaborative canvas and you want to draw a line from point A to point B. The typical user experience is that you will click on the canvas which fixates a point, then you drag the other point, deciding where you want to place the second point, and you have a line that is connecting the 2 points at any given moment. When you generalize this to multiplayer scenario where everyone is estimating and manipulating their geometries in real time, you get pretty serious performance trouble with CRDT because operations or states are frequently transmitted across the network. You require very high bandwidth for correct operations. And so for TL Draw, an application that requires very responsive kind of experience, they had to handcraft their own synchronization mechanism for themselves. Second case study would be the Penguin World prototype built by Topology. Penguin World is a game prototype that looks like Super Mario, but only multiplayer. There's a side-scrolling sandbox where each player is a penguin that can jump around and collide. The game was prototyped using YJS, so the entire game state is structured as a YJS document. So the thesis behind the prototype was that, well, it seems to be a dimension jump from a collaborative document to a game because what makes it different between multiple people editing the same document and multiple people participating in the same game state. We thought it's a dimensional jump, so we, as in Topology, proceeded with prototyping it. Synchronization works out of the box, so you can make a simple baseline multiplayer experience right out of the box with the YJS library, which wasn't built for game scenarios at all. But the tricky thing is, with side-scrolling games, one of the basic physics you would expect would be collision. Right? You want interesting thing happen when things collide, whether that's bullets or NPCs. Collision turned out to be very tricky on a peer-to-peer situation because without an authoritative server, who is to say which collide with whom first? Tricky thing with bullets, for example, did I headshot you first or did you dodge the bullet first? And if it works on top of a P2P network, there are sort of various different ways for you to, for example, pretend you didn't receive a packet or pretend you received a packet later, then you dodge the sort of the bullet carrying packet. How we prototype the Penguin World was that we implemented a collaborative kind of collision mechanism where whenever anyone collides with anyone else, a message passing happens that says A collided with B, both A and B should back off by this much and change their velocity by this much, which obviously welcomes cheating behavior. So if collision is this tricky, let alone more interesting game physics, so this turns out to be a very challenging proposal for video games. And so we can move up the stack because if you follow the local first software movement, nowadays CRDT as an algorithm is not so much heavily discussed anymore as before, as let's say 5-10 years ago. Nowadays, sort of the trendy topic would be sync engine. So sync engine sort of recognizes with the fact that when you build applications with multiple people interacting with it, all you really want is for the synchronization to happen magically. And so sync engine is a middleware that handles synchronization for your application. It takes care of network transport, and it takes care of any possible conflict resolution. So your software on top of a sync engine becomes a multiplayer version of it. A good sync engine should should have a few properties. One, it should be fast, obviously, even with very large data volumes. Specifically, there's something about initial load. When you first load up an application, so how long does it take to load up the initial state? Sort of the time between visiting a website to sort of the first render of the website. If you have to synchronize the entire application replica, it might make the initial load very slow, which would drive away internet users. Nowadays, all of us are pretty impatient online. And so sync engine's solution to this would be partial sync. And there's different algorithms for partial sync. You would sort of synchronize pieces of your application state based on their query patterns or based on client-side sort of requests or client-side patterns. So that's partial sync. Number two, it should be very easy to use. So CRDT has this issue sometimes that you expect programmers to understand concurrent programming to use the CRDT properly. Concurrent programming is not very easy to understand. Sync engine abstracts all of that so that your software on top of it becomes multiplayer instantly, ideally. Third property should be, it should flexibly support many transport options from WebSockets, WebRTC, and so on. And furthermore, it should offer access control out of the box, because multiplayer software invariably needs some kind of access control to prevent chaos. But there's one thing about off-the-shelf sync engines. On the bottom right, you can see Replicache and Electric. These are sort of two big-name sync engine projects on the market. They rely on centralized servers for synchronization. This is not to blame anyone. These communities come from very different directions. They're often sort of quite orthogonal to the blockchain community, although all of us are trying to build distributed applications with different guarantees. We want to make decentralized applications. We want to avoid or minimize the presence of centralized servers. So what can we do? So we can imagine the existence of a decentralized sync engine, which to my knowledge does not exist at the moment. But we can imagine what should a decentralized engine look like. Well, first of all, it should work on top of a permissionless P2P network. And with all P2P networks, there are sort of basic functions that typically are fulfilled by centralized servers, such as bootstrapping. But we should minimize the presence of centralized servers as a whole. And second, we would crucially need very good P2P transport layer. This is to say that when multiple users are working on an application on the sync engine, their deltas or their updates should be propagated on a network as efficient as possible. And also, not just efficiency, but also accounting for topology changes and membership churns, because people go online and offline all the time. Sort of a few approaches to achieving this will be gossip mechanism. libp2p has a gossip protocol. Broadcast trees, which has a sort of a more efficient way of multicast information on a sort of structured network. And RLNC is more catering to unstructured network, where you have a network topology that's very unstable, but you still want to make sure delivery, a guaranteed delivery as much as possible. So network coding sort of breaks up your payload into pieces and encode it in such a way that any recipient receiving enough amounts of these fragments can reconstruct the original data. That will give you sort of robustness against topology changes of the network. Potential applications of this will be censorship-resistant social media, Farcaster being the best example of this. Collaborative applications of different kinds. Fileverse with their DDoc is the great example for this. In this talk, we want to propose a probably radical idea, but maybe it's time for this. Decentralized governance platform for Ethereum itself. So this is taking a detour from the technical aspect. We can sort of look at Ethereum governance from a constitutional perspective. The three-power system, legislation, execution, and judicial branch. If we look at the Ethereum spec as the law, then all the full nodes collectively form the judicial function of Ethereum. Execution function includes different entities and organizations that are working towards turning spec into production code and managing the sort of the project management aspect. But what about legislation? Well, obviously legislation is driven by the EIP process. So this diagram, this state transition diagram is modified from EIP 1 directly. You have the state transition diagram where every EIP transitions through these different statuses on different conditions. The entire process stewarded by the core devs. Now the issue is that there are certain aspects of this process that somehow lacks codification. So number one, the how, sort of the arrows in the diagram can lack codification. The conditions, the triggers, and the entities that determine the transition somewhat lacks codification. The who problem, so precisely the authority and the accountability of the special role EIP editor may lack a little bit codification. Aside from EIP editor, client teams have significant voice in the process, but the way in which these teams are qualified and their voice is weighted or not is not exactly codified. And finally, the where problem. Discussions about EIPs are scattered on the internet across Discord server, ETH R&D, across the Ethereum Magician forum, in the PR comments of the EIP repository, and of course, in the synchronous ACD calls. It's not very formally codified how the voices of the communities is incorporated into these discussions. Well, is it time to change? In fact, the lackings, quote unquote, were actually very crucial because for example, it provides flexibility for the foundation to steer in the environment where the regulatory situation changes. It also prevents sort of formalized modes of capturing the system, because when you have rules that are excessively formalized, you invite kinds of attacks for the rules. So when we look at Ethereum's history, as it's now approaching the 10th anniversary, the ecosystem has grown explosively. Every change to the law or the spec can have profound implication to many stakeholders. So we believe that Ethereum can foster stronger trust by increasing structure and rigor in the legislation process. The entire process may be very difficult to change, but we can start from the technical aspect just to demonstrate the feasibility. Sort of fantasizing the concept of Ethereum Congress. Doesn't have to stick to the skeuomorphic language, but just as food for thought. The Ethereum Congress is a platform that centralizes all the essential discussions with respect to spec upgrades on a decentralized platform. It consists of 2 locations: the floor, where the top-level deliberation happens. It also consists of hearing rooms allocated per each EIP, so that they can be transparently and centrally discussed and edited and reviewed. On the layer 1, we can have small contracts that manage the permissions of these locations, off-chain locations. We can also have a special contract called the EIP manager that basically canonically manages the statuses and the transition of every single EIP. So we've built a prototype using OrbitDB, which we see as an approximation of the decentralized sync engine. EIP manager.sol is the special small contract on chain that canonically records the status of every EIP, whose events are tracked by OrbitDB nodes. And here we have 2 hierarchies. We have the admin DB nodes that are responsible for tracking the Ethereum events and creating new databases for hearing rooms. And we have all the users that are locally running the OrbitDB nodes with the local first software principle. So there's screenshots of the, we can't do live demos here, screenshots of the POC. Not everything works, but the repository is open sourced. The floor is the place for top-level meetings, and there's hearing room for every EIP where you have we have a forum-based interface. Just for last food for thought, a side product that is unlocked by the system is you can then build a prediction market on chain that sources information about EIP from the special small contract and have the prediction market bet on, for example, will EIP X reach final status by D date? and that sort of provides a way to poll community sentiment, which can be factored into the legislative process in some way. We conclude the talk by saying that global consensus is a very precious resource, global finality provider, Ethereum's core strength. But there is value for building coordination-avoiding systems on top of the system. And one value proposition is using this coordination-avoiding system to govern the coordination-heavy system. Both are decentralized in nature. And we proposed a proof of concept called the Ethereum Congress just to spur discussions. Thank you.
Thank you very much. Thank you very much. We have a few minutes for Q&A. You still have some time if you want to get a question in. Just scan the QR code up there and access Meerkat, log in, vote, or upvote some questions. We do have one question here. You partially answered this one already, but I'll give it to you anyway. What happened to OrbitDB and Radical? Do you use them? Are they part of your stack?
Right, we didn't use Radical, but I think it's a great point. A version control system for code should be in the picture. Ethereum spec is not written in natural language; it's written in code, and so there should be a place for such a system. But we do use OrbitDB, and OrbitDB to those who may not be very familiar with it, it builds on libp2p and a CRDT layer and a database abstraction. It follows local for software principle nicely, and that's why we use it as an approximation.
And then I think we have one last question here, just a quick one. No, we have two more. Okay, let me give you this one first. Have you tried Gun.js?
Heard amazing things about it. Personally, haven't tried it, but if I have spare curiosity, that would be the next project I try.
Great. Okay, and this should be the last one. Are you aware of the work being done with Ethereum.forum?
Actually, I am not.